Hi class, we are going to talk about the call by reference functions. So I always feel like it's easier to show you in code than talk about it theoretically. So let's do this programming assignment for myself to show you how to take four integers and find the maximum and the minimum among these four integers using, of course, call by reference functions. So the first algorithm to try to find the biggest and the smallest number in these four numbers is to basically compare the first one with the second, third, and fourth, and then the second one compared to third and fourth, and so on. So you compare basically all the numbers with each other. Then you basically even shorted the number already, and I'm not going to talk about this algorithm particularly too long, but you can see that it's 6 steps. But in algorithm 2, we have only 4 steps, so this is how it works. You basically separate number 1, and number 2, and number 3 and number 4. You decide number 1 or number 2 which one is bigger, and then decide number 3 and number 4 which one is bigger, and then compare the biggest of both. Then you know which one is the biggest among the 4 numbers, and then you compare the smallest of both, and you know which is the smallest of the numbers. So you have only 4 comparisons to do. But in terms of in doing it in a computer, there's a particular way that we are going about it. What is it? This is described in this algorithm too. So after you compare the number 1 and number 2, if 2 is bigger, then you swap it so that the bigger number is in the front. It depends on which front you're talking about. So what you are seeing, I believe you are seeing your left hand side as the biggest number. Yeah, this is the biggest number. And so you do the same for number 3 and 4. And if number 4 is bigger, you switch it. If number 3 and n3 is bigger, you let it stay where it is, because you are going bigger, the biggest, smallest, then the smallest is over here. And then now you know that this, in the position number 1 and the position number 3, they are the biggest among the 2 other numbers they compare to, and so you compare them. So if number 1 is the biggest, then you stay where it's supposed to be, the biggest number. If number 3 is bigger, you swap them. And the same for number 2 and number 4. If number 4 is bigger, you swap them. So after only 4 comparisons, then you have number n1 is always the maximum and n4 is always the minimum. We can think about this algorithm using some actual numbers like 33, 61, 0, and 88. Compare these two numbers first, because 61 is bigger, so we swap. So now n1 equals to 61 and n2 equals to 33. We compare these two numbers because 88 is bigger, so you swap 88 to the position of n3, which is the second step. So now you know n1 and n3 are the two bigger numbers, so you compare n1 and n3. And because 88 is bigger than 61, so you swap those two positions, and 88 is here, 61 is n3. So n2 and n4, you compare them, and because n2 is still bigger, so they don't have to be swapped to n4. And you see, this doesn't completely sort the whole sequence, but you know the maximum number and the minimum number, which is the goal of this project. So why do we swap in both methods? I mean, in a way, because algorithmically, it's easier to keep track of the numbers instead of having like another numbers to hold them. I mean, there's a possibility actually you can do it that way too, but then you will have to then have more numbers to hold the second. So you basically have, 4 steps. You have to have like 5 times 4 numbers, like 20 numbers to calculate. As a programmer, you always want to be efficient, right? And also, what if you have a huge number of numbers that you have to calculate? So like I said, second of all is the memory conservation. And so this is kind of like more thinking about the algorithms. If interested, for me, it's a very interesting topic. So hopefully, if you continue your path as a computer scientist, you would, start to learn this kind of thinking, how to make things more efficient, and how to do it, conserving memory, conserving CPU power, for example. So why method 2 is better? When we compare that, the most expensive thing, it depends, right? It depends on if your memory or if it's calculation. But in this case, it's calculation, definitely, because the two method use the same number of memories. Because the first method algorithm use 6 comparisons, and this method use 4 comparisons. So this is what we are going to implement. How do we implement algorithm to using a function? So I just want to let you see what it is, that we compare number and then we swap is one number is bigger, if number 2, if the number that is like this in the second position is bigger. So we always want n1 to be the biggest one and n4 to be the smallest one. But you can see that 1, 2, 3, 4, they are all almost exactly the same. And so why do we want to write functions? Because we know that it would repeat. So this is the definition of the function that I designed it for it. From now on, from this module on, I'm going to be more straight about your commenting in your programming assignment. I think previously the assignments are less complicated, and so you can still go by not really being very clear about everything, and I don't want you to have to make up stuff. But right now the programming assignments are going to be more and more complicated, and so getting into a good habit of really writing out what you are trying to accomplish with each function actually it becomes important now. So when I design this function, I give it a name and I try to write down the purpose of it. So I'm going to order the input of 2 numbers so that max is the larger number and min is the smaller number. Of course, when you call the function, you don't know which one is bigger, which one is smaller. But when it comes out, this one will be bigger and this one will be smaller is my expectation. That's why it's called by reference also, because in the last module we didn't talk about any the functions. When you have a parameter, the value of the parameter would not change, but here this value actually could change after we call the function. But continue on and you will see what I meant, or maybe you read the textbook already, which is what I hope. So parameter max and min are just 2 integers. Precondition max and min are 2 integers. Postcondition max is bigger of the 2 integers. So I kind of repeated myself here just to make sure that you understand the concept of all this, like what's parameters, what's precondition, what's postcondition. Sometimes I would use actually input and output. It depends on how the function is better described. Sometimes I write like a page of the mechanism of how my program or how my function works. It's basically a tool for yourself to help you organize your thoughts also. So this function would not return anything, because basically when after I input two numbers, I just want those two numbers to be in the right place. So so here I want to talk about the call by reference again, where like I said, the parameters passed in could change after the function calls. So why would their value be able to change? Now think about it. What are we passing in if the value can change? Actually, it's the memory address that's being passed. And that's why the name call by reference. And you can see when we declare the function, the parameters, there's an ampersand right after the data type. So this you have to memorize. It's just how it is. But this actually tell the compiler this is the address that we are talking about of max, and not the value of max that is being passed into this function. Compare that to call by value parameters that we talked about in the last module. The parameters will not change because it's just the value that's being passed, and that's why it's called by value. So in the last module, we have this remove right digit function. And you can see that we can, right now we didn't really use the number and change the value of number within this block, but you can actually change this number within this block. But once this function is done, the parameter being passed into it would not change the value at all. You see there's no ampersand here, and that means it's the value that's being passed in. So remember it. So for our project that we are going to do or show here, the expected output is like this. So we prompt the user to enter 4 numbers, and then we output say, hey, from the calculation, this is the max number, this is the minimum number. So I have a plan for this demo. We would look at the outline of the program first, because I think when I see your assignments or questions from some of you guys, some of you don't really outline the program. So I want to stress that it's very important to basically be really clear what you're trying to do before you start doing it. Sometimes you can jump into the pool and start to swim and hope that you can swim. That's one way to do it. But I think if you couldn't really make it work, outline what you're trying to do first. Like you learn the swimming on dry land first, the strokes and everything, and then jump into the pool. I don't know if that will help you to learn to swim, so don't say that I teach you that way. But for programming, outline the program first. And then because we are going to implement the order num function, I will show you how to write a driver to test that function before you finish the whole project. Because if that function is not correct, your program would not function correctly. And then at the end, I will show you how to test the program, because I realized a lot of you hand in the homework, you did great, but because you didn't test your program and then you missed something. So I would like to minimize that kind of careless mistakes. As a programmer, you need to test your program so that other people don't have to deal with it. Think about it. If you have a teammate, right, his program, his functions are always not right, and your function have to work with his function. Think about how much you would like this person. Okay, so let's go to